We started off by saying that SEO you shouldn't be platforms, that you shouldn't take best practices on basically what then you start comparing SEOs and
Yes. Did you have some or? Do we have the? Yeah, I was gonna say. Yeah.
Small company, it's not like basically like every job was in a different type of environment. Now basically we kind of have one developer for each kind of thing. So I'm doing like front end that does Android. There's one developer that does embedded software development for Postman. There's one person kind of doing like actual electronics schematics, instrument, build or whatever. Someone else checks. There are some overlapping like skills that more people have, but everyone's doing the different things. Like it's kind of like we have a responsibility for one aspect of the whole thing. Well, yes and no, because I depend on some stuff that other people are doing. So I need an API to get the data from the server. So someone else builds that for me, and I don't do it. So basically, like, have to make sure that I'm doing the job so I can use it.
Yeah, because when
Yeah. How about you? How many years have you been left doing what?
company
I'm assuming it's good.
Drop the school in the middle.
In theory, once you have experience, that's going to matter more, but started off.
It's not so kind of, job. Get a diploma and then I have even bigger thing.
Bad experiences also.
Especially this year we have multi-camera. So, bigger amount.
Hey, you want to practice? Like, got a perfect setup here. Like, if something goes wrong, we don't really care. But yeah.
No. It can be.
I know that. I'm saying you gotta practice stuff you haven't done before. We don't mind. We don't mind. I recorded the talks last time. I still have them on my computer. I haven't done anything. People actually emailed to ask, like,
So, if you could,
the thing is, like, I have, well, I've got final cuts as well, like what I like to do. It's not that big of a deal. It's just like finding the time. But I haven't found the time to close my company. I still haven't. Like I've been an employee for over a year. Last couple of years.
download. Just put the 500.
I should email. I should tweet the link.
Yeah, it's working now.
Is it the one you sent me? Or
Yeah.
put 10 on your phone yet? Put iOS 10 on your phone? You put iOS 10 on your phone? Because I know I sent you
I have, actually I didn't even, I'm not sure I have, yeah. Still I have,
because I sent you.
so now I have,
Oh, not even the link.
I always, later.
What? Because I sent you that, like I usually didn't.
I saw it.
Because like, because these are like the new Don't be sorry. Don't be sorry. Okay, so I went here to get the link and now I'm like, structure, new shiny thing.
Yeah, it's the same one.
Big stuff.
When I buy cake, it's much more stable.
Like, if it works. Yeah. Oh yeah, that's it. Although, like, talk to Mark. Mark.
conference today.
Yeah.
So I'm carrying camera around. I should have brought a tripod.
How's things with you?
It's alright. I'm looking forward to this week being able to do several big things I'm trying to. So I was just in Brighton for 2 conferences last week, so it was fun. But it's got over and done with.
I was on holiday Portugal last week, but
Nice.
still it's a bit.
It's quite nice Brighton. SEO conference, so it was Brighton SEO.
Yeah, okay. I
Oh,
know.
it's massive.
Yeah, I know. Someone mentioned it. Like,
Oh, right.
someone did, like, the guy that used to
Oh, cool.
back a level up. Now, like, basically, he took his company to London.
I think it was like 3,000 people. It was giant.
It was
It was packed. The keynote was hilarious. It was one of these SEO people who gets very over the top and likes to deny for anything but a corner of Google. So it was, it was an interesting day. It was just up in a 3-day design conference. It was quite interesting.
Do you have an underscore at the beginning or the end?
Weird. Someone took this initially without underscore years ago, and this account is ready, but Twitter never responded. I tried to reach them a couple of times and ask them because no one used this account, so they could delete it and give me it. And they never responded. So it must be underscore.
That's okay. One more. One more slide.
Yeah, have fun. I'm cool.
Quite quiet today. Not as many people as usual.
Turnover of the academic student society, the graduates and professional or examining somewhere. We once have a conference.
Alright. Plus the weather is not helping.
Reading in here.
Yeah, no. Hi everyone, welcome to Edinburgh TechMeetUp. Hello, speaking here. Hi everyone, welcome to Edinburgh TechMeetUp. I'm glad you all managed to make it. I'd like to thank our sponsors who made this event possible: Skyscanner, Informatics Ventures, and Cultivate. I've got one question before we start. Like, if this is your first time at TechMeetUp, could you raise your hand, please? Okay, cool. Welcome. Before the if this is your first time here, like the way we do things is we're gonna have introductions, then followed by the talks. But before we do that, I want to point everyone, like, the fire exit is there. There's no scheduled fire alarm, so if you hear an alarm, just head that way. Leave everything, just head that way. Another thing I'm going to ask you is don't lean on the tables at the back or any tables, because we've had an incident where someone fell and we don't want a repeat of that, as funny as that was, but anyway. Right, so I guess what we're going to do is just, like I said, do introductions, and the way that works, we say our name and what we're here for. So just to kick that off, I'm going to start first. Hi everyone, my name is Marius, I'm an iOS developer, and I'm a TechMeetUp organizer.
I'm Douglas. I know almost everything there is to know about barcodes, and I'm about to bore the arse off you in the next few minutes.
Hi, I'm Richard. Just started a business doing image sensors.
Hello, I'm James Baxter. I'm a developer of Works Open Tech Calendar. I've been doing some stuff around some tech sites I'm going to be talking about next month. But first of all, I hope you all find it useful. Good, it's payback time. This weekend I'm cycling 50 miles for charity in the borders, very hilly hills. Please sponsor me. Thank you very much.
I'm Amy. I'm a PhD student at the University of Edinburgh, but I've been in the US for the last year and I'm just back visiting for a few days, so I thought I'd stop by. And I now work for W3C.
I'm Xavier, I'm a software engineer and I'm here for the talk.
Hi, I'm Michael. I'm a deep developer at GBG, and we are currently hiring, looking for senior software developer. So if anyone's interested, please come and talk to me.
I'm Rumi. I am a software developer. I'm working on optimization and security.
I'm Chris. I'm an IT manager at CryptoBlue, so the optimization stuff. Well, talking about IoT with MicroPython.
Hello, my name's Jamie. I'm a lawyer and I specialise in helping startups and tech startups with their legal stuff.
I'm Steve, I work for Analog Devices and I lead the code generation team where we produce code generation tools for embedded systems, and in real life I've been banging my head against Django migrations and having a great time.
I'm Murray, I work with Steve in the code generation team. I completely ignored this Django stuff. I'm just genuinely curious as to what's going on.
Hi, I'm Jakob. I work mostly on front-end and user experience, and I work with this guy.
Hi, I'm Alastair Andrew, and I run a company that writes optimizations.
I'm Karen. I'm an intern at a pre-ordinary startup. Every now and again, my boss calls me the tech department.
I'm Rachel. I'm a full-stack developer. I'm an entrepreneur, and right now I'm really grateful for James's Open Tech Calendar, because it's reminded me that this time next week, I'm doing a talk that I'd forgotten about. If you're interested in Firebase, which is Google's real-time database and mobile app development, please come out to Goderburn at the RBS headquarters and listen to me talk about Firebase. Thank you very much.
Hi, I'm Ryan. I'm a common methods researcher at the University of Edinburgh.
Hi, I'm Ali. I'm a data engineer at FanDuel. I'm involved in Girl Geek Scotland, where we've just launched a mentoring network, which is open to people of any gender. You can sign up via the website.
I'm Nathan. I'm a designer and a colleague of the guy in the festival yellow.
I was going to say that.
I'm Antonio, I'm a telematics engineer. I'm working as a front-end developer / mobile developer.
I'm Jorge, in Spanish. I'm currently here for the last 2 weeks. So I'm in Edinburgh in order to start looking for a job. In the future, I would like to study a master's degree in global sustainability.
I'm Scott. I'm an enthusiast for all things tech, like JavaScript and Python. And I sadly use Windows XP at work. I'm also the brother of the man in the offensive video. I will mention his hackathon. I'm Peter. I'm the one wearing the offensively yellow t-shirt. Yes, I know. There's no hiding in this thing. So the hackathon is I'm a front-end developer. I like JavaScript. Don't like public speaking. That's why I'm here. And I was at a hackathon over the weekend in Belfast, which was awesome. We won first place.
Hi, I'm Hemel. Freelance software developer. I work in C# or Java.
Hello everybody, I'm George. I've been a senior software engineer for the last 6 years, and now I'm here in Edinburgh at what's
the artificial intelligence at the University of Edinburgh.
I'm McCallum. I studied at the University of Edinburgh.
Hi, I'm Spud. I'm a co-founder looking to launch a student recruitment network and looking for investors.
I'm Ken. I'm a data engineer who works in Python. I'm also a digital nomad. I used to come to TechMeetUp about 5 years ago, so I'm back here to see what it's like.
Tim from Flex Venture. We do custom word prediction. I'm also looking for consultancy in computational linguistics, if anybody knows anyone. And funnily enough, we are doing, in 2 weeks' time, if you search on IoT Edinburgh, we do an Internet of Things meetup, usually at Naked, it moves around sometimes to some places, on the Internet of Things and startup funding. So that's 2 weeks, look up IoT Edinburgh.
Hi, I'm Andrew. I'm from Administrate these days. I'm here because I haven't been here for ages, and I just wanted to have a bit of a chat. And also to deliver a shameless plug. Thursday, Friday next week, Administrate is putting on the UK's largest EdTech conference. It's going to be amazing. If you're at least vaguely interested in either the conference or the amazing after party, come and speak to me later. I'd like to chat to anybody about that, or EdTech, and if you're just a little bit more into coding. I started working on Enlightenment in my spare time again, so if anybody still uses that, if you're really interested. Wow.
Hi, I'm Alastair. I'm a freelance software developer. I'm working in C++ with video and image processing, and I'm looking for some help. You know somebody else who's got some of those skills that are useful. Thanks.
I'm Ross. I'm a product manager at FanDuel, making the next generation of fantasy football for the UK. I'm here because every few months I get a bit guilt about not being technical enough, so I think this is a good way to kind of appease that a bit.
I'm Traco. I'm a student. I also work at a startup. It's called Drupal, and you can check it out if you actually need something about music, if you like music and people. So work as a front-end and back-end developer.
I'm Stephen. I work with Ross on FanDuel UK product. So I'm here because I haven't been for ages and thought it would be kind of good to come down the stairs.
Hi, I'm Hugh. I'm an engineer working with data at FanDuel. We use Python, Amazon Redshift, Apache Spark, and Hadoop.
Hey, I'm Alex. I'm founder of the recommendation and marketplace for photographers. We're just transitioning from a web agency to a full stack developer, so we're hiring.
I'm Ian. I'm here because I like stacking chairs at the end of the evening.
I'm John. I'm John. I'm a front-end developer, mainly using Angular development to contracts. Just started contracts for a place called Route Monkey to make routing for delivery companies.
Hi, I'm Daniel. I'm a web developer, mainly using Ruby and Scala and JavaScript. Here mainly for talks and things.
I'm Chris. I'm a software developer at college.
Molly, I'm Saturday, and just take the talks. Thomas, I'm a project administrator for an energy company. I've also just started studying a master's degree in IT security at Edinburgh University, and I'm here for the talks and free system.
Hi, my name is James. I'm a software developer at Free Agent, which is online accounting for humans. I've also organized the McCallum, which is the Ruby users group in Edinburgh. And Free Agent is hiring senior engineers and also product development. If you're interested in that.
I'm Davide. I am doing my last week at Cobol, which is a bootcamp about software development. And yeah, I'm looking for a job as junior software developer.
Like Davide, I'm also just finishing my Cobol as well. My name is Russell.
I'm Alyssa. I'm a CS student at the University of Edinburgh. I'm a freelance Rails developer too. I came because I was going to meet someone here who ended up not being able to come. So I am just going to see what it's about, I guess.
I'm Paul. I'm videographer. Came for a record and stream this event. So if someone cannot came, you can send them a link to our channel on YouTube for this video.
Hi, I'm Mark. I work for Brigade on virtual networking stuff. I also help organise the talks for TechMeetUp. So if you're interested in giving a talk or know somebody that would give a really good talk, please come speak to me, or there's a GitHub for TechMeetUp that you can raise an issue on. And if you'd like to volunteer in any other way, just come and speak to any other volunteers and we'll get you sorted out.
Did we miss anyone? No? So, if anyone has any announcements they'd like to make, any events? No? Right. Well, then we're going to take a 5-minute break to set up first speaker. So I think it's going to be Douglas. If you don't know, like the toilets are outside reception as you came in through that door. You'll see the left or right depending on where you need to go. So we'll see you back here at 7:45. It's been more than 5 minutes, but
It's all working as expected this month. It's all working as expected this month. Everything's fine.
Slide streaming now.
Huh?
Slide streaming now.
Hi. Nothing to worry about. This never goes wrong. I've been catching up with some of the live streams that I missed. Yeah.
Or if you want to speak.
Yeah, I've been catching up with some of the live streams I missed. It's really good to kind of have everything recorded. It's pretty good quality.
I have a plan to get a second camera. There's a software kind of mobile editing system. I mean, you can switch on an iPad. You can switch. You can connect machine for cameras. Right. You can switch like like Sudoku commander. So you can dangle maybe another camera there or on a speaker close closer to show the speaker, and maybe third source as stream from with the presentation. So we could
register off that, I think, but also cool, okay.
Video will be more now we have only one. It could be boring. I mean, boring from the physical side, because the content is obviously for someone at the visual side.
Yeah, like definitely. I think definitely having being able to split between the slides and
because sometimes usually people cover big letters, big words, it's fine, yeah. But sometimes code or something, it could be better, to grab the screen and put on a full screen on a
Douglas. Well, toilet break.
Yeah.
Next speaker is also
Is that from Switzerland?
No. Also from Switzerland is leaving. Going off to do something else. I think he's taking a break. Also somebody else is going to be the liaison. And then somebody else again. Tonight there's a big deal. Not tonight, is going to be more regular. So he's not sure tonight. They'll still be quite happy to have it.
That change not affect us. Okay.
I think it still should be pretty engaged with TechMeetUp there's other events as well.
Okay, so it's not only our event.
Yeah, no, there are some other events. Where we store the drinks. We get a whole cupboard. There's another cupboard with like shelves for the other.
Oh wow! For for myself, like quite nice. Very old technology, but it's quite simple. You can do really a lot of stuff. Especially I'm a collector,
right?
So for me, it's like a personal stuff. So talk about when I get experience, I write something. Yeah. Take a, for fun, because it's useless now. But I think people will remember.
If there's any audience in Edinburgh, what do you think more things being more things being like there's a lot more ideas like control. I suspect you might be touching on a lot.
What?
Explain.
I'm a application collector, right? And now I start learning Apple Connect. Why not? Yeah. For fun, because it's useless now. Yeah, but for fun. Yeah. Because I was going to say, do you mind if I ask you to speak to my dog? Right. If you don't speak, you get me.
That's right.
Okay. Yeah, why not? I can't see why. Because the history of stuff is just as important. Yes. Because I was trying to have history in my talk. I'm finding trying to recognize I think still better boy, it was a terrific device. Really? Yeah.
Tell you what, I'll give you the gimbal.
Actually, Cobol guys, they developed some software. I'm ready to now. Web server. Developers. Some guys use Wi-Fi cards for you. Hey, so I have a Wi-Fi, including Wi-Fi and so no, that's really cool. Well, go and still watch it and still, you know, you can do all of the that'd be good. Cool.
Well, let me know when you're ready. That's it. No, let me know when you're ready.
Yeah. Something, you know, something for fun. Entertain people, yeah.
And like, it's a nice thing about TechMeetUp. There's no, because it's just technology at large. Right? There's no specific focus.
Yeah.
Like, and most folk coming along, they're not. I suspect most people don't come specifically because they know there's a particular talk going on.
Yeah.
They're mostly, they come along for beer and pizza or to meet folk and because there might be something interesting.
Yeah, maybe. Yeah, especially maybe.
So yeah, I think that's well in the wheelhouse. So. Alright. Oh, me. Right.
1 minute. 1 minute late.
Right, everyone, if I could get your attention, please. If you all have a seat, we're going to start with the first topic of the evening. Right, talk is starting. Have a seat, please. Right, Douglas.
Appropriate way to do it. F11. Before. No, I just saw it.
So loud, obviously.
Full screen.
Right, okay, first of all, a little plea before we start. we need speakers. If we don't get speakers, you get me. And the thing is, I have never sat out there watching me, so I don't know how good or bad I am.
You're okay.
Okay, so how come none of you are using Cobol? I'll bet nobody here is using Cobol. I see no hands going up. I started off in Cobol. And one of the things about Cobol is it has a bit of a bad reputation. And the whole talk is about how perfectly good languages go in life support, never to recover. Nobody in their right mind would start a new project in Cobol these days. I actually quite like Cobol, but I wouldn't start a project in it. I would get paid huge amounts to maintain it, but I can't be arsed working in a bank. The interesting thing is, once languages go like that, they never come back. There are plenty of languages that have never come back from the abyss. So, what's wrong with Cobol? It isn't popular. Nobody uses it these days. But it used to be number one. Between about 30 and 50 years ago, that's all people used. It was the number one language by a huge margin. There was Cobol jobs, which took about 3/4 of Computer Weekly, and then there's a little bit at the bottom of everything else. But where are all Cobol programs gone? They've gone on somewhere else. One of the complaints about it is very wordy. One of the things I like about Cobol is the wordiness of it takes away complexity. Because it's much harder to be complex and say, move field X from record thing to Y, typed out in long words. Cobol is easy to understand, and complexity is a killer of decent applications. APL is the exact opposite. It's not wordy at all, but nobody ever programs in APL. Even back in the Cobol days, nobody programmed in APL. So we're going to have a little quiz. Anybody know what those two programs do? Why not? Top one is a grand total of 17 characters, and it finds all the prime numbers in 0 and R in 17 characters. That's APL for it. Game of Life, the Conway's Game of Life, 41 characters. You'd be hard pushed to do that in another language, but you would never use it. Nobody in the right mind would use APL either, because it is a bit hard to understand. So, you can't run a web server on Cobol. Well, you haven't looked hard enough, because you can. Think of Cobol and Cox. I did some research for this, and I found it. And that's what it looks like. That takes me back. Best ever keyboards were an IBM 3270 monitors like that. Great keyboards. So if you want to run a web server with Cobol, A, you're mad, but B, it can be done. So it is going to be boring and going on about too long. So we shall move on. In the beginning, there was machine code.
Yeah.
Now, for those who haven't seen it, that is machine code. Quite obvious what's happening there. The trickiest job I ever had was writing a machine code bootloader for a mini computer. And to test it, you had to get a bit of Mylar tape, convert machine code to binary, punch holes in the tape, and then run it. And if you made a mistake, it was another 20 minutes of punching holes. It was not fun. Luckily, this is the Apple II machine code monitor entering thing. And as you type stuff in, it told you what you're doing. It saves a lot of time. However, the Lord looked down upon machine code, decided it was pretty shit. So along came assembler. This is going back early days. I have had jobs in assembler. I like assembler. If you don't like commenting stuff, just don't bother with assembler. You have to comment it. You haven't a fucking clue what's happening. So they decided that in the other beginning, there was autocode. First ever high-level language. Invented in Manchester in the late 40s, early 50s to run Ferranti computers. Ferranti was one of the first companies to actually sell you a computer. In those days, they reckoned they would sell 1 or 2, ever. And the world's first computer salesman worked for Ferranti, and he was sent over to Montreal to speak to the St. Lawrence Seaway Company about selling them a computer. And on the way over, because he went by boat in those days, he was sharing a cabin with a guy who sold lighthouses. And they had long conversations in the night about who had better both job prospects. And they both decided it was the lighthouse salesman. But that is also good. That is what you are doing. That's where it stems from. It didn't last. I have worked for Ferranti and I've never met anyone who's used Autocode. So what we had was sort of the decent high-level languages. When I say commercial organizations, that's IBM. Because IBM were flogging computers. They flogged more computers than ever. And there was fuck all you could do with them. You paid 2 million quid for something that would sit in an air-conditioned room and just sit there, and it would just take money from you. So they had to program it. So along came Fortran, Cobol, #1. RPG was report program generator, which just sort of read a database and printed text out. PL1 was IBM's equivalent of Algol, or Pascal, for those of you who don't know about Algol. Then the 60s, we got to a stage where universities could afford a computer. So you had all these professors of computing science who finally had a computer. So all their ideas of a language, thought, let's try it out and see what happens. And you get a lot of things. You've heard of most of them. I've used most of them, never used Snowball. I have seen Snowball ads, but I have never met anybody who did it. So then we moved on. The thing about the 80s, just like the Apple's machine code thing, you could buy your own computer. You could buy a computer and you could take it home. And once that happened, you didn't need to have a university department to design a language. You could do it yourself. So you've got PHP, which is early 90s, Python, early 90s, C++ in the 80s. One person could design a language. In most cases, it was a bloody mess, and nobody ever used it. But you could design your own language. That was one of the beauties of it all. And then lastly, we moved into the stage where the big organizations have realized. So we have C++, C#, which is Microsoft, Go, which is Google, Hack, which is Facebook, Swift, which is Apple, Rust, which is Mozilla. The interesting thing is there's nothing from Amazon. Because Amazon have exactly the same problems as all the other things, and they haven't done a language to sort the problem that we know of. I have no idea. And there's no Amazon people here tonight, so I can't sort of quiz them and they can look shifty. But these companies have big, they will do more stuff than you will ever do in your life. And they know what they need to do, so they've designed languages specifically to solve their problems. And in a lot of cases, they're actually really good. C# is a bit different. I'm going to mention a thing which sort of has a go at C# later on. Because C# is the oldest of those. It came from 2000. All the others are sort of late 2007 onwards. So, why do languages die? I don't care what you're writing in the moment, it's the equivalent of cuneiform. There will come a point where only a few select academics will be able to translate it. Because a language generally comes around, and language is around for no more than 25 years. Somebody designs it, it starts off, a few people use it, and then it gets popular. And there is something about the 20-year thing, it gets to 20 years, and they just move on. It gets done. Cobol lasted 20 years. Pascal lasted 20 years. Python is hitting the 20-year mark. But interesting, and so is Ruby and things. But I have data that says Python may survive for a wee bit longer. So why do they die? False promises and unmet hype. There's one person in this room who's programmed in Ada. In the early 80s, Ada was the only language you would ever need. The US government has said, if you are going to quote for a job for us, it must be written in Ada. Because they looked at their stuff and they had like 285 different languages for stuff. And they thought, this is a bit silly. So they said, from now on, Ada or nothing. One person in this room has anybody ever heard of Ada? Okay, not a huge amount of you. The trouble with Ada is it came along at the same time as the IBM PC. So essentially you had Microsoft saying, fuck you, we're selling Windows. We'll make our money from Windows and DOS. And IBM saying, well, we're supporting Ada, but nobody's buying mainframes anymore. So you got that, you got false, and it was hyped. Everybody thought we're going to have to learn Ada. The other thing is languages get ignored. A good example of this is Pascal. in the 80s and early 90s, Pascal was the language of development of small machines. Apple came out with a UCSD Pascal, which was a P-code interpreter, which ran on an Apple II. It used 48K of memory and had 2 disk drives if you were lucky. And it was terrific. And the early Macs we had to develop in Pascal. And the best compiler ever, which I mentioned before, was the Borland Turbo Pascal compiler. It was terrific, fantastic compiler. Unfortunately, it was DOS only. And Microsoft, who also had a Pascal compiler, there was a heap of shit, decided, oops, our Pascal compiler is a heap of shit. We can't have these Borland people taking our money from us. So then they made it C was the development language of Windows. And the Turbo C compiler was good, but it wasn't as good as the Turbo Pascal one. Hardware changes. Mentioned earlier, Apple II. The Apple II ran in a 6502 processor. It could address 64K of memory, and it ran at 1 megahertz. And it was designed in 1975, and Apple and Commodore and people used it because it cost a sixth of the price of the Intel equivalent, which is the 8080. So it was designed in 1975. When do you think they stopped making it?
They haven't.
Correct, they haven't. They sold 100 million last year of a 41-year-old processor. The other processor at the time was the Z80. They're still making it as well, 100 million units a year later. But the thing about the hardware is all these languages like Cobol and Ada and things could not run on a 64K machine, which is why you really started with assembler. And they had BASIC for people who were dabbling, and then Pascal came along, and you got slightly more memory to use. And all the microcomputer compiler design ignored Ada and Cobol and all the stuff had gone before. Although there was nothing wrong with it, they just couldn't run it. So everybody who comes along gets his things, they start dabbling, and they start dabbling with Pascal, and they don't dabble with Cobol because they can't. The last thing is there are some languages that kill themselves. And we have a prime example at the moment. And in this, I am predicting the future. And the trouble with the future is it comes along and proves you're wrong. But the example of a language that's killing itself is C++. Now, quick glance should tell you what that do, all you C++. I know there's some C++ people here. For the rest of you, the output from that program is that. Except it isn't. That's the output from C++ 11. If you run it from something like C9, from 99, you get little eyes in the stars. If you run it in different version, every version of C++ gives a different result in the middle of the star. And that's not really very helpful if you want to run something. So you spend all this time doing stuff, think, oh, well, I haven't changed it, it should have no problem. No, you can get puckered over. The next way is committing suicide. C++ 17, about to come out next year, hence the name. They've decided to add a few new features. And I can't read that from here. So, probably you can't read it. Template argument deduction for class templates. Template auto. Non-type template argument fixes. Those are all the new features going into C++ 17. There are, in fact, 94 of them. Now, the interesting thing about when you get lots of features in a language, you don't use the full language. You end up using a subset of the language. And somebody else uses a different subset. And the other bloke uses another subset. So you can have 6 people using the same language in totally different ways. And that is one of the reasons why C++ is about to kill itself. I have evidence that it is. 94 new features is roughly the same number of features as Go, Closure, and C combined. Sorry?
It's about right for C++.
Yeah. So, the other thing about it is they've taken stuff out, which is just so fucking annoying. Whoever thought, we'll take this stuff out, should be shot. Because suddenly your stuff will stop working, you will think, it worked last week. So, anybody know the painting? John Constable's The Hay Wain. Painted in 1827 of Suffolk. It was given to the National Gallery in 1886. This is relevant. So it sat in the National Gallery for 130 years. In that 130 years, Not one single person has decided there's not enough helicopters or McDonald's or nuclear power stations. Sorry?
Banksy did.
Okay, luckily didn't get to the original. So you have that thing that says, for fuck's sake, leave it alone. It's like George Lucas in Star Wars. He just cannot bloody leave it alone. Does anybody ever think that Star Wars is any better because when Harrison Ford walks around Jabba the Hutt, he steps on his tail and goes up a bit? No. If your design is good, leave it. So, trends in languages. This is where we're heading for. Concurrency seems to be the end thing. So the world seems to be heading towards microservices. And you need concurrency for microservices. One of the other things that seems to be happening is simplicity. Rich Hickey, who designed Clojure, has a really interesting talk. It lasts about an hour of his principles behind designing it. And he sat down and thought, how can I make this simpler? What can I throw out? Because complexity fucks up your stuff. Complexity causes more problems than just about anything else. The Rob Pike, one of the guys beside Go, they spent a year working out how to do numbers as constants. And the way they do numbers as constants is numbers. They don't care. You define it as whatever it is, and the compiler will take it into context. So if you say number, temperature equals 32, if you need a float, it's a float. If you need an int, it's an int. And they've also decided that the design they've come up with is what sticks. They're not adding anything to it because they've spent 5 years thinking about it. And you saying, I want generics, doesn't count. Classes and objects are history. I can remember when objects first and classes first came out. It was Byte 1982 August edition. Smalltalk 18 was the cover. I thought, shit, objects are great. And then I saw the next step, and I thought objects were brilliant. And now I've been using objects for 20 years. I think they're getting in the way. Objects have a lot of problems with them. The trouble with inheritance is, okay, you can inherit the behavior from the class above, which inherits from the class above that and the class above that, and then it inherits behavior on that. And you have to take all the shit that comes with it, not just the bits you want. And the trouble is people are really bad at doing classes. They put too much in. And so you get to inherit too much shit. And that's one of the problems with classes. Because all the new languages, apart from C#, don't have classes. C# has them, but that's Microsoft, and they have fuck all idea about design. So, what should you be looking for a new job in? This is taken from the Stack Overflow Developer Survey of 2016. These are the 9 most common languages. The table has 10 in it. The number 10 is SQL. So cut it out. There is an argument of why SQL is history as well. But that's another talk, if you don't volunteer to be a speaker. So you can see from the left, JavaScript, Java, C#, PHP, Python, C++, C, Ruby, and Objective-C. JavaScript, bit in the slide. Java, bit in the slide, not helped by Oracle. Oracle don't give a shit about Java. They want to make money from it, and they can't see a way to do it. So that Java has problems. The only way they can see you doing it is suing the arse off people. It didn't work with Google. C# is actually showing quite a big fault. If you're working in C#, think about learning something else. It might be helpful. PHP is on a bit of a slide. PHP isn't very well suited to concurrency. And I don't know about PHP 7. James here? No. Anybody know about PHP? Does PHP 7 have concurrency in it? No, right. Because we're moving to microservices, it's going to get a bit stuck in that. Because the other thing with hardware changes is, again, this is the future coming up to bite me in the arse. The history of hardware is it gets cheaper and cheaper. In the early days, you had mainframes. And I had a boss who defined computers by the delivery method. A mainframe came in a lorry. An IBM mainframe came in 2 lorries. One lorry for the computer, the other lorry for the manuals. Really do. You've got a lorry load of manuals, and the manual really does say, this page intentionally left blank. Mini computers came in a van. Things like Vaxes and Data General Eagles and things. And a microcomputer, one person could carry them. We now got to a stage where you're all carrying them in your pocket. In the 80s and 90s, up till mobile phones, you couldn't carry a computer in your pocket. Now you can carry it in your pocket. Google hardware. Google, when they started, back in the early, there was 4 main search engines in the early days. There was Alta Vista, there was Excite, there was Yahoo, and there was somebody else who I can't remember. And Alta Vista ran on VAXes, big mini computers. They didn't have many of them, but they ran on mini computers. Yahoo was the same. What Yahoo did was, Yahoo's method of search engine, optimization, people read the pages. They had humans who read the pages and worked out what people should look for, which obviously is a method that doesn't scale. It works if you've got 100 million pages. It doesn't work if you've got 100 billion. The other was Excite. Excite was a big one. They used Sun microstations. So they had thousands of Sun workstations, which are not cheap. And then Google came along. And the way Google did it was they bought motherboards and disks. They didn't bother with cases, they didn't bother with power supply, and they had racks of car batteries. And the car batteries would drive the servers. 12-volt car batteries would drive the servers, and they would plug them into the wall, and if the power lost, they had enough battery power to keep going for a few hours. And the way we are heading is an Intel Celeron, which is a fairly shit process, costs you 110 quid if you went out and bought one. A 64-bit ARM will cost you 5 quid. The world is heading towards you get 100 ARM cores for the same price as a Celeron. And now you've got a 64-bit ARM, it's going to whip the ass off it, and it's ideal for microservices. And I think that is the way it's going to go, because it doesn't matter what you think, it's what Google and Amazon thinks. If they think that's how they're going to run their data centers, that's how they're going to run their data centers. But they won't cut the prices, they'll just make more profit. So anyway, the languages. Python is the only language on that list that's on the up. It's not great at concurrency though. I'm prepared to argue afterwards. C++ is committing suicide. There is the evidence. It is on the slide in a big way. So is C. One of the problems with C and C++ is they're not memory safe. We're living in a world where security is really important, and not being memory safe is a significant thing to think about. Ruby is slightly on the slide, and then Objective-C. Objective-C is easy to explain because Swift has come along, so people move over to Swift from Objective-C. And so finally we have the last slide, which is, that's it. Right, if you have a question.
Questions?
So thank you first of all for that trip down memory lane, because that made me feel really old.
I think it's important people know the history.
You missed C off the languages in the 80s.
C is an interesting one.
But that's what my question is this. Do you not think that what we're doing is moving towards domain-specific languages, where we're using those languages to find the particular subsets that we want, or to frame the vocabulary in a way to solve the problem, while simultaneously what we're doing is we're trying to change what you said about concurrency in microservices. That's not a language problem, that's a programming problem.
There always were domain languages, like RPG was quite widely used, and it was for producing reports from a database. RPG, then you read a database, sorted some stuff out, did a bit of fiddling, and then printed it out. There was no manipulation of the database, so it was a domain-specific language. Fortran is fairly domain-specific if you're doing scientific stuff. So I would argue that we are using stuff for domain-specific stuff now, but we always did. It was just different stuff before.
I think that the best languages, the best way of developing languages, and that comes from like universities or companies or individuals or like big open source project type things. I think the best. So
It comes from people who have an idea that they know what they're doing. Because a lot of these things is, I mean, like C++. The people behind C++ just listen to peer pressure. Oh, can we have this? Can we have that? No, okay, it'll shut you up. It's not going to make the language any better. It's going to make it probably worse, because all these things they added are computationally intensive. So what might take, what's the compiler? It might take half an hour to run, but it's one line to type in. And that's one of the problems. It's like, it's things. The best language come from people who know how to say no, not people who know how to say okay. And I don't think it makes any, because Go, which I rather like, comes from Google. Closure, which I never use, is one blow, sitting in his own. Hack is like Facebook, all of them. So I've never used Hack. I know a little bit about it. I had a talk from Facebook about it. So I can't comment whether it's any good or not. So the answer is yes to all of them, but no to all of them as well.
So you said you like kind of closure, and that's one guy hacking away in a room. Do you think there's a kind of risk of having like a kind of single key man, for example, like kind of Peril or something seems to have lost its way and naturally kind of associated with one guy's vision? Do you kind of see like something can start off nice and then someone kind of veers off piste?
Yes, there is that problem as well. Perl I was going to mention as one of the things that has fallen out of favour for no real reason, other than it's a bit hard to use. So she's going to disagree. I've not really used Perl much. I've dabbled in it, so I don't know. It's not a language that's ever interested me. And they also always shut up.
Other couple of kind of quick points and questions.
Yeah.
So I would disagree that most of what you said is basically your opinion.
Yes,
So just to take one example of data, from data point of view, I think there was a stack overflow question in that graph.
Yeah.
So that what you're actually measuring there is, you could argue, not don't believe yourself, you could reasonably argue, is how difficult a language is to use. And so you can't necessarily factor out what is the thing that you're actually trying to measure here, some goodness factor of the language. You can't use stack overflow data like that directly, both either to support or refute your argument.
It may also be a factor of like the number of people who are actually using it. I prefer the graph of the number of swear words in comments and per language, which I think PHP was somewhere near the top.
The Stack Overflow thing, it's a question they ask every year. What languages are you using? It's not which languages you like, which languages you find, which languages are you
So
using?
equally, well, that can be just flavour of the month. So for example, you could argue that the reason that things last for 20 years is because developers get older. The same thing that happens in science. The reason that things do in science is because people die. You could argue that the reason that new languages get invented is because inventing new languages is fun. That's what fun things that young people do, not older people.
Right. By mentioning programmers get older.
I'm going to recommend either like asking a question and a response, or just taking this to the pub.
My point basically is that I disagree with the argument because it's not really based on evidence, and most of it's just opinion.
So you're doing the next talk then?
Yes, next talk. What I said was changing people's
Oh, maybe
Right,
one final point. I think you're missing a trick with SQL. Because if you look at, so just take one example. If you look at things like Spark or any kind of like big data stuff, what's tended to happen is that they come up with bespoke languages, but then they tend to go towards SQL or SQL-like syntax because that's more problem focused as opposed to implementation focused. So SQL ends up being a commonly used language across many different systems, even if it's not technically exactly the same SQL, like how SQL or SQL or whatever. I would argue that SQL will outlast most of these languages because it's problem focused as opposed to implementation focused.
What's your evidence for that?
Right, I'm genuinely happy to cut this short. Right, we're going to take a quick 10-minute break and then we're going to have the second talk. And see you then.
So I guess why do I want to do CP for the Sudoku Intolerant? So CP is constraint programming, and if you've ever learned anything about it, often people will just say, oh, it's brilliant for solving Sudoku problems, and that's all you learn about it. Like, you see a kind of blog post, and oh, I smashed this really hard Sudoku problem by using constraint programming. And it's just like someone saying, oh look, I did select star from users, and that's what SQL's about. Like, it really kind of does it an injustice. Who am I? I'm Alastair, and I'm so interested in constraint programming, I thought I could start a company that does some constraint programming, which was obviously mental, but it's quite good fun, and we're still here, so. What is constraint programming, I guess? So it's a kind of, when people hear programming, they think, oh, okay, most people think of a kind of imperative language, and I'm telling a computer to do something. But CP is really very much kind of declarative kind of paradigm. So you say, you pose a problem, and the computer gives you the answer. I really like, there's a quote by Pablo Picasso, the knowledgeable computing lecturer, stroke cubist artist, and he was asked about computers. And he said, computers, they're useless, they can only give you answers. And I thought that was quite a nice kind of like throwaway comment, but I think he's doing kind of answers disservice. Like, humans are good at coming up with questions, and if we've got a way of getting answers for free, then that's awesome. Yeah, it's part of my downfall. One of the kind of, where I became interested in constraint programming, I went to Cork when I was a lowly PhD student, and they were running a summer school in constraint programming. They have a big kind of research group, and constraint programming will always be associated with the death of Michael Jackson. That's kind of being drunk in a Cork bar morning. The kind of pop and constraint programming are all kind of intertwined in my mind. So so if I get a bit emotional, it's probably that. I'm going to talk about Minizinc. So that's it's really a modeling language to kind of express constraint programming programs in. So that's really what I'm going to kind of do for most of the talk. I'll kind of talk about how we model a problem, and I'm not actually going to really discuss the underlying which solver you should use, because there is quite a lot of difference, and there isn't really a standard. Everyone has their own implementation. I'll kind of touch on that. I'm going to do a bit of live coding, or have a car crash, that'd be fine. I'll talk a bit about how it works, like at a kind of high level. But really, again, it's kind of like SQL. You really shouldn't need to know like exactly what's going on under the hood. And if you just leave here with a vague impression, go, oh, that's interesting, I can take some of those concepts and maybe use it in your own work, then this has probably not been a car crash. I'll give you some kind of links to other things if you're interested. So, what's it good for? Solving Sudoku. No! Yeah, okay. Solving discrete decision problems, really. So a discrete decision problem is where you have to make a definite option. You can't sit on the fence. So you get other technologies like linear programming, which is really, this is all some of the stuff that Douglas was talking about right at the start of computing. People like kind of Danzig and Wolf and all these kind of guys who are really mathematicians were interested in solving optimization problems that you could model as a series of lines, and really you were trying to work out what the intersection of those lines were. And for them, like a kind of valid answer is, well, we take 7/5 of this item and put it in your knapsack. And really, we're interested in discrete problems where you need to say, I'm taking this thing, or I'm not taking this thing. This class that I'm trying to timetable, it's happening on Monday at 10 AM. It's not happening, half of it's happening on Monday. Like, you need to make a proper stance. And really that's constraint satisfaction problems. So where you have a series of decisions that you need to make and restrictions over those decisions, and you're looking for an assignment that satisfies those decisions, or it's totally valid to get kind of, no, sorry, computer says no back. The other one's constraint optimization problems, where you have some notion of goodness, some sort of objective that you're trying to do. So for vehicle routing, it would be try and find the shortest route that you can. For job shop scheduling, it's usually the make span. So when is the last thing that you've allocated in your crazy scheduling problem? When is it getting finished? Earlier is better. You get kind of load balancing on things like servers. There's kind of been various problems around that, and it's kind of interesting. Constraint programming allows you to express these problems quite concisely and also take into account a lot of the side structures. So you rarely encounter a clean problem. You often find one with a whole bunch of kind of interesting side constraints, and it's really the ability to model those efficiently. That's what kind of constraint programming is good for. So ManyZync, it's by a group of researchers in Australia, NICTA, who are their kind of national something ICT Australia organisation, and they have a big optimization group, and they're trying to develop the kind of de facto standard constraint programming modelling language. But so were Opal, who they were the kind of optimization programming language that was commercially backed by iLog, who are a kind of French company who've been sucked into IBM, or closer to home, Essence Prime. If anyone's from St Andrews, then that's kind of, they had their own kind of constraint programming group, and they wanted to make Essence Prime their kind of de facto modelling language. Or someone decided they wanted to do models as XML. If you're some sort of masochist, then fine. But that's kind of some of the competition problem sets are expressed in XCSV. Or AMPL, which is often something to do with linear programming, and I don't know. There's a chain of kind of failed attempts to be the de facto kind of constraint programming language of choice. This is one of the kind of more recent ones, when they actually got a Java standard through to try and express just specifically for Java constraint programming, like this is how you should model it, and no one does. So there's been a train wreck, a series of attempts, and ManyZync's the kind of latest of those. But you know, like insert obligatory XKCD, which often kind of sums up things. I'm sure everyone must have seen that, unless they call yourselves a TechMeetUp. Anyway, yeah, so the reason I chose to do it was it's got a decent editor, people are actually using it and developing it, and it's got some decent resources. So if you went away after this talk and you were interested, you would probably be able to pick it up. And there is a decent chance that it'll still be on the go in 18 months, which is, for computing, as good a guarantee as you can get. The one thing I'd say, so it's not a CP solver. Like there's a compilation process essentially. So we're going to write a model, and it's going to, under the hood, it's going to get compiled out into a kind of flatter language, kind of almost like a bytecode called FlatZync, and then that's handed off to some other piece of technology that solves constraint programs essentially. There's various ones of these. The one in green is the one that we're actually going to use. That's G-code. It's developed by a guy who is now at NICTA, and they've been doing that for at least 10 years, so it's fairly stable. Choco is French, it's a Java constraint programming language. Oscar's primarily Belgian, and it's in Scala. Minion, I think, is in C++, and it's from St Andrews. Those are all kind of coming out of academia. They're from the industry. There's iLog, Cplex. Chip's quite an old one. It's from the kind of 80s or 90s, and Opturian's, like again, the kind of 2000s. It's a kind of recent startup in Australia. So there's various kind of people writing constraint programming solvers, and really ManyZync allows you to speak to a variety of backends, and that's much more common in the kind of world of mixed integer programming, etc., where you would express a model, and then you would be able to solve it with a different technology, and that's why I quite like ManyZync. Wish you could see what my it comes in different flavors. You get kind of prologue-y ones as well. So the idea of kind of having constraints and doing inference and thinking about kind of discrete logical problems, that's very much Prolog. And so some of the kind of constraint programming languages syntactically are basically variants of Prolog, which makes them kind of unpalatable to the modern eye. But if that's your bag, go for it. So you can do Eclipse, which came out of Imperial College probably in the early 90s. Sixtus is some sort of Scandinavian thing. Or you can go down the iLog route. So they were the kind of the premier commercial software providers, and they decided, sack it, we're not going to make a language, we're just going to make a C++ library, though they didn't know it was obviously a terminal decline. But they thought, well, we'll make an C++ library, and you can just create constraint programs in raw C++, calling some special functions. And other people have kind of gone down that route. That's more common. So OR tools is Google's own kind of collection of constraint programming stuff, and it encompasses a lot more. So you can interface with various kind of mixed integer things, and it's got some network flow, solvery things, and some heuristic search. Choco is the same idea, but it's in Java. So yeah, everyone's just constantly reinventing the wheel. And it's really because there's kind of different motivations. So in academia, people don't get, you don't get your PhD for coming up with a nice constraint model. You get it for coming up with a more efficient algorithm that propagates a particular constraint. So everyone will kind of end up writing their own kind of really simple constraint system that has its implementation of some specific constraint, and it won't have half the other ones that are interested in. And in industry, they'll create a bunch of constraints that people actually use, and they won't have all the other ones. So there's this kind of divide, basically. So it's quite hard to find something that has everything. So hence why I decided I would just do the whole talk in MiniZync. So the kind of concepts are, you get some parameters, some immutable kind of facts about your problem that you're trying to solve. So that'll be kind of how many of something there are. And you get variables. Those are the decisions that you need to make. This is really the kind of heart of it. The domains are the range of values that those variables can choose from. The constraints are an expression of the restrictions on the valid choices. So to satisfy the problem, like all the constraints need to be satisfied. You can have an objective. Sometimes that's just satisfaction, like find me any valid assignment, or it can be optimization. So you can express some sort of numerical objective function that allows you to kind of differentiate between different variable assignments, and you can come up with something that's actually, you know, in this situation, you've satisfied all these constraints, but this is better than that, which is useful in most cases. So I thought what I would do is kind of ground it in a problem that I stole from The Guardian, like all these liberals. So this is a real kind of Monday maths puzzle that appeared on the 4th of July. So it's kind of vaguely recent and vaguely Brexit themed, which is nice. So I've kind of pulled it out. And it's just a kind of classic logic puzzle. And I thought, well, what we'll do is we'll go through that, and I'll kind of show you how you break down the kind of process of extracting what the different aspects of the constraint model are, how we would model that, how we'll get an answer, and then we'll kind of talk about how it works. Does that sound okay? Silence. Okay. I see a mistake completely from start. Okay, well, go on. So basically, if I switch on the mirroring of displays, and it is. So this is the kind of this is the MiniZync IDE, and you basically have some nicely syntax highlighted code and a little kind of output window at the bottom. You can have projects and associate kind of data files with them. Okay, and we can kind of run that, and we'll get an answer, which isn't very exciting at the moment. So the only thing that's mandatory is this kind of statement here, like solve satisfy, and effectively we've done that because we've not told it anything interesting. We could jazz that up a bit by having an output statement, so that we can actually get an answer, which would be good. So the output statement is probably my least favourite aspect of Zinc, in that it kind of expects an array of strings, which means that when you see a nicely formatted one, it's pretty awkward. Oh, wow, hello TechMeetUp, how are we doing? Good, you're all excited by some constraint for that. So, the first aspect is really, so what were the parameters of that kind of problem that was in, can we switch back to it? So, cool. So these are the kind of things that are fixed. So we've got these 6 British interpreters that are at the EU. They all have kind of strange alliterative names because that's kind of how people like to phrase problems. So I've highlighted them in green. Those don't change, and they're not something that we need to decide. Then we've got the constraints, which I've highlighted in red. So they each speak 2 European languages. No one speaks the language indicated by their name. No 2 interpreters speak the same 2 foreign languages. Each of the 6 foreign languages is spoken by only 2 of them. Spike, who's the Spanish guy, speaks Dutch and German, and his cousin speaks Dutch and Polish. Fran and Dudley speak all the languages not indicated by their names. Blah. And the question that we're trying to answer is, which 2 languages does Ron speak? And so the decision that we need to make is which of the languages, which of the 6 languages does each person speak? Or really all we care about is Ron, but effectively we need to model it to work out what everyone does so that we can express the remainder of the constraints. So, what do we need? First of all, we need parameters, which I've cunningly saved here. Saved this a lot. So we've got these are the kind of fixed variables. They have types in Minizinc, so there's integers. You can have a set of integers. You can index an array by a set of integers. You can also have kind of floats, booleans, most of the usual types. And these are all basically constants. We don't have any notion of making a decision about these values. We're doing a straight assignment. Then I'll grab this bit as well. So I've made a few arrays in this case so that we can actually make a nicer answer. And we get a kind of, you can see what I mean about an absolutely horrible output statement at the bottom. This won't compile until I say what languages are. So that's all the constants. Then we need to kind of define actually what is the decision that we're making. And so this is this kind of statement that we're going to use. I'm going to say we've got an array of decisions, and in this case they are there's an array the same size as interpreters. So for each one of the 6 EU interpreters, we need to know what languages they speak. The var is the key part, so this is the decision variable, and in this case it's a set that has to choose from the set of languages. So what we've defined is 1 to 6 basically, and that's called languages. We don't make an assignment or anything at this point, and that's the kind of point of the search. So we run that, we get this really exciting output where actually Ron speaks all the languages. So great, are we done? No, we need to actually kind of enforce the restrictions of the problem. So the first one that we saw in the thing was that each interpreter only speaks 2 of the languages. So the way that you express a constraint, you take this handy keyword, just in case Minizinc didn't know that you were trying to do a bit of constraint programming. And then, in this case, we want to say that everyone, so all the interpreters, we want to kind of express the same restriction over them. So for every one of these, we want to say that the cardinality, like so the size of the set of languages that they speak is exactly 2. So we can do that by enforcing this restriction. I guess in most programming languages you're usually kind of used to seeing equality represented as a kind of double equals or something. That's very common. In constraint programming, this is almost like, it looks like an assignment, but there isn't really a difference between an equality you enforcing that equality and you checking it. So in this case, we're saying, I want the cardinality of person I's language to be 2. So if you run that, okay, cool. Now Ron speaks French and German. And it's still compatible, which is always good. So then we need to say, actually, you know what, you don't speak the language of your own name. So how would we express that? So for everyone again, we need to say, okay, this restriction applies to them all. And in this case, the in, this is quite kind of weird, but the in this case is creating a Boolean expression. So we're saying either this will create an extra Boolean variable in the decision problem that we haven't explicitly declared. It's kind of hidden in the constraint. So we're saying, okay, is the language I in the languages of the person I? And we want that to be false. So what that should mean is that if I take out this restriction at the bottom and we can see everyone's languages, we should see that that's now true. So, okay, so Spanish Spike doesn't speak Spanish, Guy doesn't speak Dutch. Okay, so we're getting somewhere, we're getting closer to what the problem was. So the next one is like no pair of interpreters speak the same 2 languages. Again, we're going to need to kind of do a pairwise comparison on these. And this is kind of interesting. So these are 2 sets that we're comparing. Like the variables themselves, often you would see in constraint programming people expressing restrictions between just single integer values. And in this case, we're saying actually these 2 sets of multiple values aren't the same. So we could, we also kind of have this extra clause in the generator function. So we're saying actually because it's a binary relationship, like if I and Jai are not the same, then Jai and I aren't the same. So we don't need to go both ways. So we can save ourselves a little bit of effort. If I can do typing right.
No, let's
Straight.
try this.
Ah, no. You guys are on it. Cool. Okay, so we've kind of managed to express that they don't speak the same language. Each one's spoken by only 2 interpreters. That one's kind of difficult to do, but I might come back to that one. This one's kind of easier. So we basically steal this one. So this is almost like a direct, this is kind of information that we've already been given in the constraint. There's no other choice. So we're being told that Spike speaks only Dutch and German, so we can kind of create a set on the fly that contains just Dutch and German. And we can enforce that that's true. We can say, yeah, cool. So he speaks just German and Dutch. Then we need to do someone who isn't him speaks a different combination of languages. So in this case, what we're doing is saying we're using exists. So previously, the for all is basically an intersection, like a logical kind of and of all these individual constraints. So we could have kind of written these out in long form. Could have done, you know, for 1 in languages 1 equals false and 2 in language. In this case, exists is basically it'll hold if only one of if there's any example, well that's true. So that gives us a bit more. So we're getting closer. Then Fran and Dudley speak only the languages which aren't in their own names. So we need to kind of work out what the languages they speak, and in that case we need to do a kind of set union to get like all the languages that they speak. And then we need to work out actually which languages aren't in their names. So we can do this kind of set comprehension basically. So we're building up a set, going across all the languages, and then we're filtering out the languages that are their own names, that aren't their own names. say, okay, so Dudley speaks 2 languages, and the people whose namesakes are that he speaks, they don't speak French. So in that case, what we need to do is embed his own language. So we need to iterate across the variable that represents the languages that he speaks, and then express a constraint over that, which is kind of an interesting concept. That's okay. Then, so finally, if someone speaks German, they don't also speak Polish. And in this case, we've got a kind of interesting situation where we've got a reified constraint. So we've got an implication that the second part only holds if the first part is actually true. So in this case, going across all the interpreters, we're saying if they happen to have German amongst their decision variable, amongst the values in their variable, then the second part must also hold that they don't have this language. So that ability to express things that are conditional in some sense on other decisions allows you to create quite rich models in this case. And the final one, which I kind of avoided, is that each language is spoken by exactly 2 people. So we need to kind of do something a bit cheeky, and we need to kind of collect together. So we need to use another function basically, and this aspect of it. So we're collecting together these Boolean expressions. So we're getting an array of Boolean expressions, and this function asserts that the number of true values within that's 2. So, and then hopefully we should get an answer. And if we put back the clause where I wrong, then we've solved it by a huge amount of cutting and pasting. So we have discovered that Ron speaks French and Spanish with very little mental effort on our part, apart from you apart from all the work that everyone's done underneath the hood to allow this to be done. Okay, so that's true. Okay, so DNA and DFW DNB says, I think that Ron speaks French and Spanish today. So we were right. And then they actually give us quite a long and detailed explanation of how they arrived at that value. Gone to page 2. I particularly like the bottom. Sorry for this very long and drawn out path to what I believe is the right solution, but I am new to these kinds of puzzles. Yes, thanks very much. But effectively, what we did is not that different from what this person has typed in an enormous Guardian comment. CP, like, so constraint programming is really the combination of search and inference. And in this case, inference is propagation, like, or is usually kind of referred to as propagation. So what's happening is that the constraints that we were expressing in that model, they know which variables that they relate to, and they're informed of changes whenever the variable's domains. So whenever a value is removed from that domain, they're never added. But at each point something changes about the variables that they're listening to, they get a chance to think about their own internal structure. So they get to think, actually, do you know what, like, I've been told that Spike speaks Dutch and Spanish, so I better get rid of all the values that aren't Dutch and Spanish. And then anyone else who's listening to that variable gets told, oh, by the way, like, he no longer speak, or he can no longer speak French or German. And they get to think, oh, does that have an implication? Can I infer something from that? And can I remove values from the other variables that I care about? So in our kind of model, we had a couple of unary constraints. So that's one where there's only a single decision variable in it. In this case, we were doing the cardinality. So the right-hand side is a fixed expression. So as soon as we kind of stated that, we can do some inference. Or maybe not in the cardinality constraint. it's probably a bad example. It would be better to use the one where we were explicitly saying which languages the guy could speak. Binary constraints are where we have two different decisions on either side, and we can kind of use, we can infer things when we state those. So if we have to say that they're not equal, and the domain of one has two values and the domain of the other has just one value, well, it would be bound to that value, and then it would be removed from the other one, and you would get an answer. What we didn't use is global constraints, which are constraints which consider far more than just one or two variables. So the classic one's all different, which is what everyone always talks about when they do constraint programming, and it's because it has really elegant internal solutions. So rather than decomposing a problem into a series of kind of binary relationships like this, they gather all the things that they want to say are all different, and they use some graph theory to create a bipartite graph and knock out loads of edges, and it's all very clever and academics love it, but we didn't need to use it, so sorry. So that's kind of part of it. Like, propagation only gets so far, and I guess the thing with Sudoku problems is actually propagation will probably get us all the way to the answer if you've got a decent starting point. So if you think about the way you solve them as a person, you should be able to infer your way to the complete answer, unless someone's messed up making your Sudoku problem, and it's really challenging. In terms, so the point where propagation failed is called the fixed point. Once you've kind of looked at the constraints and you've ruled out all the values that you can, and you're stuck, basically, there's nothing else that you can infer from that information. That's called the fixed point. And at that point, we need to start the search. So we need to kind of make some decision. And usually it's a branching decision. So we usually kind of make a choice. And in one branch, we say, okay, yeah, I'm definitely going to keep this thing. And on the other branch, well, I guess if we end up backtracking or we make the wrong choice, so we can tell the wrong choice when we run out of choices to make. So the idea is that we assign a value to every variable, and we find ourselves in this kind of position where, oh, actually Spike can't speak any languages, or there's no languages left for him, then we need to kind of think, we've probably made a mistake, and we need to kind of go back. Some of those choices that we made must have been wrong. So, you know, when the facts changed, I changed my mind, which I thought was main Arcadens, and then I did a quick bit of Googling and found out that it was clearly not main Arcadens, so I thought I would just kind of preface them. Yeah, so like backtracking is essentially when we unwind those decisions. Like, we've kind of ended up in a state where something's not right, better retrace my steps, put the things that I'd ruled out back, get back to the point where I made an actual search decision, and then I better go down the other branch, in this case, by asserting usually the kind of opposite condition. And in some senses, the kind of branching strategies, you can do different values and things. But effectively, that's what's going on under the hood. There's some notion of we can infer information, get stuck, we need to make a decision. Did we get an answer? Oh, we made a mistake, must have done something wrong. Let's try the alternate decision. And I guess, I might do it for time.
5 minutes.
5 minutes, okay, like, so this was kind of really interesting problem, which I've stolen a kind of slice out of someone's academic paper, a guy called Pierre Schaus, which sums it up really cleanly. But I find it really interesting as a kind of topic, but you can use it for really chunky industrial problems. And the one that really kind of caught my eye was steel mill slab design, and you can read all that exciting text when I post this slide online. But effectively, it's a problem that occurs from steel mills. They came out in the kind of late 90s, and they have a kind of series of orders that need to satisfy. People try and buy steel, still apparently, and there's kind of different ways that can be processed and different amounts that they can deliver it in, and it's trying to kind of satisfy those orders for steel without wasting any. And the problem they had, that was proposed in 1998, had 111 orders. There's about 88 different ways that this kind of piece of steel could go through the machinery. and you could only buy it in 20 sizes, and that was pretty intractable. For about 10 years, people were saying, oh yeah, we've solved it, we can satisfy 30 of the orders from this, or we've got up to 70 of the orders from this kind of single instance, like a single problem, and they thought we were doing well. And then some guys proposed a paper in 2007 which smashed it to bits. They basically just tore it apart in under 3 seconds. And the thing that I really liked about that paper, or just in general about constraint programming, is look, they didn't do anything new. They didn't invent any new algorithms, they didn't invent any new propagation, they didn't invent anything. They basically took what was existing and they combined it in a different way. So they took their model and they just made a few changes in the way that they selected variables. They decided to use a few existing constraints in an unusual way, and it just tore apart what people had thought was previously unsolvable, or was practically unsolvable, and dominated it. And they saved the steel industry, and no steel mills are shutting down. And that's anyway, I thought that was kind of interesting that they basically they used kind of things in a new fashion, and I think that's something that we can all kind of take heart in. That any of you could go out there, take a kind of what clever people had thought was unsolvable, and potentially just rip it to shreds. So if you are interested in this rambling chat, then I would suggest have a look at Peter Stuckey's Coursera course in modelling discrete optimization. He's Australian and he's the kind of main head honcho behind the kind of optimization group there, and he does a nice Coursera course about modelling problems. There's a Swedish guy called Hakank, I think that is his name, but he has a really good blog where he models loads of constraint programming problems in the same problems in different languages. So if you're really struggling to pick up a new language or a new kind of specific formalism, if you decided you don't want to use Minizinc or something, then absolutely hit up his site, because it's just a really good way of translating between the concepts of those things. There's also the Minizinc people run a challenge, so they propose interesting modelling problems. You can go away and have a look at that. RoadDef, which is French OR guys, they also do some really interesting kind of challenging modelling problems that people submit different approaches with, so they try and represent it as constraint programming or mixed integer and all sorts. If you're feeling really brave, go and have a look at the Global Constraints Catalogue, which is a terrifying collection of about 500 or 600 different global constraints, but you'll struggle to find a system that implements even a fraction of those. But often it will kind of give you what can be implemented and kind of point you towards the papers if you really want to get your hands dirty. And another really interesting link is Helmut Simonis. It's about 5 years old now, but he's run a kind of half-year-long project when he was documenting industrial kind of constraint programming applications. So if you want some ideas on what people have done with constraint programming and like the actual kind of practical applications that aren't kind of just kind of tinkering with Monday's Guardian Maths challenge, have a look at that. There's a whole bunch of really cool stuff that I could talk about all day, but I'm not gonna. Just get out there and start using the technology that's out there to solve interesting problems. Don't go about reinventing the wheel, because I'm sure like some of you will encounter interesting decision problems in your work in completely different contexts, and you'll probably make a half-arsed attempt at doing your own thing. Don't use some constraint programming and smash it.
Thank you. So because we have to be out of here quite quickly, we're just going to take 2 quick questions. So,
did you see the solving Sudoku problem? Did you see when you tried to use depackage and the dependency calculations to solve Sudoku?
Well, yeah, dependency package calculations an interesting challenge that some people tackle with constraints. It's a similar idea, like reasoning about what the implications of what you need to do before output. So yeah, I haven't actually seen that one, but I've seen people kind of talk about some of it. And in the back.
So maybe allowing around with logic programming a bit here and there. Like a lot of this seems to be very similar to that, to stuff like Prolog, and you said that at the start. What's sort of, I guess, the difference between the two? What is
I guess like, so logic programming in the kind of prologue senses, you know, you have the head and you resolve it to the tail and all that kind of just I'm not really, like, I can't give you a concise answer of what, I mean certainly computer programming arose out of that idea, like from that kind of field, but I couldn't tell you why logic programming's kind of fallen out of fashion. I think it was probably, you know, the whole kind of rise of global constraints that allowed you to kind of tackle much bigger problems than just kind of simple clause resolution. And I haven't even mentioned SATs, so it's something from there.
Cool. Thanks very much, Alastair. I'd like to thank our sponsors again, Cascada Informatic Venture, Informatics Ventures, and Cultivate. If you could help us kind of just put cans at the back and bags and stuff. We're going to go to the pub, which this time is going to be doctors and less than stock days, but doctors. Yeah, so when we see you next time, take care. That's it. Do you want a slice of pizza? Yeah?